Okay guys, so I'm going to show you the problem that we did before, which was 9.2, so 59 and 2/10 divided by 8, but how we would solve that if we wanted to do partial quotients. So the first step when I'm doing partial quotients, I get rid of the decimal point and I rename the number in a way that I don't have to write the decimal point. So instead of doing 50, oh that was ugly, hold on. Instead of doing 59.2, I'm going to call it 592/10. And I figured that out by knowing where my last place value was, which was the tenths, and then just taking the digits. So you name it by the last place value and you complete the digits. So here's how we go to solve. So when you're doing partial quotients, the first thing you want to do is always list some friendly facts. So I did times 1, times 2, and times 5. But what I noticed was that only got me up to 40, and I'm dealing with a big number. So I took times 1, times 2, and times 5, and added zeros to those to get larger pieces. Times 10, times 20, and times 50. I want to start subtracting with the biggest number in my set that's closest to 592 without going over. When I look down my list, I see that that's 400. So the first thing I'm going to do is subtract 400 from 592. Now when I do that, next to that 400 I subtracted, I need to write the number of how many times I just took 8s away. That was 50 times. Okay, now I subtract. 2, 9, 1. Okay, so now I'm working with 192. When I look at my list, 400 is now too big. I need to go with a smaller piece, so I'm going to go with 160. When I subtract 160, I'm taking away a times 20 chunk, so I'm going to write 20 next to it. I'm going to subtract 2, 3, and I end up with 32. Now when I look at my friendly numbers here, I've got 40 and 16. I have no 32 on my list, so I have to figure out where 32 is. I know that 32 is really close to 40. So instead of 8 times 5, because that's too big, I'm going to try 8 times 4 and see if it gets me close to 32, and it's exactly 32. So that was 4 groups. And I end in a 0. When I have subtracted all the way down and I end in a 0, I know I'm done. So now when we do partial products, we want to look at the numbers we wrote over here and combine them to find out how many groups of 8 we were able to make. 50 plus 20 plus 4 is 74. So my answer is 74, but it's not just 74, it's 74/10 because I renamed it. If I want to write 74/10 in standard form as a number, I would write that as 7.4. Notice that I got the same answer when doing partial quotients as I did doing standard algorithm.